Welcome back to my channel. So in the previous lecture we have studied about the S, which is single responsibility principle. We have seen that what does it means. We have also we have also seen the code which doesn't follow the SPR principle, and we have also seen which follows the SPR principle, and how can we convert a class which is not following the SPR principle to how it should follow. So we have also seen that conversion, like how can we convert it. So in this lecture we are going to see the next principle which come under the solid, that is O. So the O stands for the open closed principle. In the short form we call it as OCP. So what does it means? So if we see its definition, it means that software entities should be open for extension but closed for modification. Okay, so what does it means? That okay, first of all, what does entity means? So the entity means the class, okay, a single class, or you can say entities means that let's say a student, you have a student class, so the student means the entity. You have different class, let's say teacher, so the teacher is entity. So a entity should be open for extension but closed for modification. Okay, in simple word, you should be able to add new feature without changing your existing code. Okay, and you can achieve this through abstraction and polymorphism. So if you guys don't know about abstraction and polymorphism, so you guys can comment it down. I can make a separate video on this, but yeah, so let's continue with this video. So what does it means that it should open for extension and should be closed for modification? How does it help? How does it help our code? So if I am saying that classes should be open for extension but closed for modification, so in doing so we stop ourselves for modifying existing code, which may cause potential bugs. Okay, so let's say you have one code. Okay, no worries guys, I will explain you this through the code. So let's move on to the next slide. How can we deduct OCP? How can we deduct a code is violating the OCP? Okay, so every time if you are adding a new feature to your code, existing code, you are modifying the existing classes. Okay, what does it means? We will see through this through the code, but for now you can understand it that, let's say if you have a class which is responsible for sending notification. Okay, so let's say now you are trying to add a new type of notification, that is push notification. Previously you have, let's say, email notification only, but now you are trying to add a push notification to your existing feature. So if you are trying to add that push notification to your existing classes, so what it is doing is, it may be happen that if you are adding it to the same existing classes, it may create a bug. Because why? Because your existing code, that is the email notification, is already tested. Okay guys, so let's say the email notification code is already tested, but now you are adjusting the push notification to the same classes. Okay, so let's say for the adjusting the push notification class, you might have to do some modification in the email notification also. So what happens is that now the email notification also become untested code. Okay, so this may create a potential bug in the future, and we have a overburden of testing the existing code as well. So we have lot of problems if we try to adjust a new feature in the existing class. Okay, so yeah, there is one example. Let's say if adding a payment method requires editing a payment service instead of just adding a new class. Okay, so you can do one thing, you can add a new you can make a new class for push notification. In this way what happens is that you don't have to do any changes in the email notification, or you don't have to change or you don't have to touch the email notification. Okay, you can create a separate class for push notification. You can do all the logic for the push notification in that push notification class. Okay guys, okay, so now we are going to see the code. We are going to see a code which is violating the OCP, and how can we refactor it to follow the OCP principle. Okay guys, so first of all let's see a failure case, like this is the failure case because it is not following the OCP principle. Okay guys, so let me walk you through this code. So this is the payment service. Okay guys, so let's say it have one method that is process payment. Okay, you guys might have a credit card, or you guys might have a debit card. You can have different type of payment method. Someone do GPay, someone do phone pay, but we can have lots of different methods, okay, to do the payment. So now you have done a code which accepts a payment type, or you can say payment method, and do the process according to that. We have one credit card, we have PayPal. Okay, so let's say someone have a credit card. Okay, and we have written a logic to process the payment to the credit card, and we have PayPal logic as well. Okay guys, so how is it violating the OCP principle? Okay, so let's say tomorrow we have one let's say tomorrow in market a new type of payment method have came. Okay, let's say we have GPay, Google Pay. Okay, so now we have to integrate this in our code in the payment service. Okay, let's say this we have to add a GPay method as well to process the payment. So what should we do? Okay, so you guys can say, yeah, it's easy. We can just write in this, let's say type dot equals GPay, and it's we have a GPay logic. It's done, it's good. Okay guys, yeah, it look cool, it will work, but it's not a good approach. Why it's not a good approach? Because let's say what happen is that when you're trying to add this logic, or you are trying to add a GPay payment, what is happening is that you are doing the modification in this payment service class. This is the first point which we should avoid it. We should avoid already tested code. Before adding this GPay method, our code is tested and is running in the production. Okay guys, but if we adding this GPay logic to our existing class, it is a failure case. Why? Because we are changing the logic in the same class. And the second point is that, let's suppose if you are adding a GPay logic, but for adding a GPay logic you need some code from this PayPal and from the credit card. Okay, so you should do the you will be forced to do the modification in this as well, which is again a failure case. We should avoid it. Okay guys, so if I see the problem, let's say adding a UPI payment means modifying this class. So in short, whenever we are adding a new feature in our existing class, we are violating the OCP principle. We should avoid it. We should not do it in the existing class, because it is tested. We have already done the testing for that. We have already deployed it to the production. And first of all, your manager, if you are working in a good, well reputed company, so your manager is going to your manager is not going to agree with this solution. So what should we do? How should we make this follow OCP principle? So this is the code which is following the OCP principle. Okay, guys. So how is it? If I show you side by side. So this is our previous logic for the payment service, and this is our new logic. Okay, guys. So what are we doing in this? How are we making it to follow the? Just a minute, guys. Okay. So how are we converting this to follow the OCP principle? So first of all, make a interface, a parent interface like payment. Okay, guys. It have a one method which is pay method. Okay. So there is one parent interface, that is payment, and it have one method, that is pay. Okay, guys. And let's say for the in future, if you have some different methods, this is pay method. Okay, let's say in the future you have some different methods, so you can add those different methods here in this payment interface. Okay, guys. So this is the interface, and we have three concrete classes. Okay, we have three different concrete classes which is implementing this payment method. Okay, we have a credit card payment, we have PayPal payment, and we have one payment service class which is already we have. Okay, guys. So the credit card payment method is implementing the payment, and it should give the logic to this pay method. Okay. So this credit, we have separated this logic, logic into a different class. We have made a different class for credit card payment, we have made a different class for PayPal. And let's say now the client came. Okay, now the client doesn't know about this. Okay. So let's say now a client came, and it is saying that he is going to pay through the credit card. Okay, so he is going to pay through the credit card. The credit card logic should run. Okay. So now let's say in the future you need to implement GPay logic. So now you are not going to do the changes in the existing class, because the class is following only the specific type of payment request. Okay, it is responsible for the credit card payment only. So by doing this separation, you are avoiding this. You can say that you are avoiding the failure cases. Now let's say you need a third type of payment. Let's say you need a GPay also. So you will come here, you will make a GPay payment. Let's say you are making a GPay payment which is implementing the payment interface, and you will write the logic for GPay. Okay, guys. It's done. You didn't change it. You didn't have to change in any existing class. You didn't have to modify any existing logic. So by doing this, let's say how are we how have we converted this existing class which is not following the OCP principle to follow the OCP principle. So by doing this, now we can add any number of UPI payment. We can do GPay, we can do phone pay. So by adding a new type of payment, we just need to create a class which will implement this payment method, and which will give logic to this pay method. So yeah, so I hope I was able to make you understand the OCP principle. So if I can summarize it, so basically what you have to do is, whenever you have a different type of if else logic, or you have a different you have let's say you can say a single job, you have a single job, and you can do this by multiple ways or multiple type. So you should follow this OCP principle, because if you doesn't follow this, you will keep do the changes in the existing class, which will not be beneficial for you, because you have to retest the whole code again And if you are doing the changes in the existing logic, then it will take too much time to deploy it to production. Because why? Because first of all, you have done you have done changes in your existing component, or you can say existing code. So first it will go through the QA will test it. QA have to test the existing logic as well. This is just a one class, it have only three if else. Let's say you are working on a production code. In the production we have thousands of lines of code. So the QA will need to have to test whole thousand lines of code again. So it is overhead, it consume time, it consume resources. Okay, so you should definitely avoid it. So yeah guys, now let's go to the okay. Now first of all, let's see how we have done this. So we have created a interface, parent interface. Now the and we have three different type of concrete classes which is implementing this payment method. Now let's say we have fourth we have a new type of payment request came. So the new payment type of request will implement this payment method. So yeah guys, that's all for today. I hope I get this video gets long, but I was not able to show that I was able to explain you properly or not. But I just want that you guys should, if you guys are watching my videos, so you should be able to resolve all your doubts. So guys, if you have any doubt regarding this OCP principle or any other principle which I have already taught you, that is uh, SPR principle, so you should definitely do a comment. And you can do a comment like how can I make myself better at a teaching. If you want, I can add diagrams, or should I use any other ways. So you can feel free to comment this. So okay guys, bye.